The printer halting like this on a long 3D print can be very frustrating, and you'd want to see if you can't salvage the work, salvage the material, try to pick up where it left off. Here the halt was created intentionally. It's a small piece. Had it been allowed to complete, it would have become the soda can lid that can be found on Thingiverse. The first thing that we have to deal with is that the nozzle is probably frozen right into the work, so we have to bring it to its operating temperature. And then and only then can we move it up. And there's going to be a deposit on top of the work that has to be dealt with. And the knife is not the best tool for that because we may apply pressure and dislodge the workpiece off of the bed. And if we do that, all bets are off. So either these small snips or a nail clipper will do as well. To be able to pick up a print where it left off, one of the most important pieces of information is at what height was it when the print halted. And the print had already progressed into this narrow area here, this thin lip. And that is from where we're going to have to try to pick up a measurement. So today's video is going to be about how you get that height measurement, the Z-axis, without the benefit of a log that tells you where it halted and that you actually have to take a physical measurement. And for that, you would need good control of the X, Y, Z axis, and I think that Octoprint provides that best control. It's a very narrow lip that we're trying to position the nozzle in line with, so that we can drag a piece of paper and try to see if we can't pick up that height. So I have the nozzle directly positioned over top of that lip. And I can read the Z position at 2 millimeters here. I'm close, but that's too loose. I'm going to go down 1 millimeter. That's nice being able to do that. Still loose, 1.9, 1.8, loose, 1.7, it's loose, 1.6, loose, 1.5, there you go. Too tight, see? Going to go up 1. 1.6, and the paper is free. That's the height that it left off at. Had the print halted before it was into this lip area, when it was still in this wide area, we would have been able to estimate if it was like 1/3 done this layer or half of it done in this layer. On the lip, it's very hard to tell, but I took a close look at it, and my best guesstimate is that it was about 90% done, that pass at 1.6 millimeter. Notepad++ is the go-to software for us to edit these 3D printer G-codes. We're going to find a G-code file for that pop can lid. And we're going to edit with Notepad++. Now we need to find where Z 1.6 was. Control F, Z 1.6, find, there it is. Let's erase everything before it. Delete. Now we have to try and find where Z 1.8 started from. Scroll down. And there it is. So we got about 250 lines of code that comprised Z 1.6 before it was going to index up to Z 1.8. And without the benefit of a log file, we're kind of guessing at this. And as I just finished showing you, it looks to me like it was pretty much all completed. Anywhere in here would be just as good a guess as any. I'm going to erase everything starting up from here. I'm going to save this file as resume can lid. So of course, we can't just go and execute a G-code starting from here. There would have to be a lot of G-code lines inserted that initialize the printer, like up above here. And there will be, but we're going to leave this method here of finding Z without having the benefit of a log file. In the next video, we're going to explore how you find Z and other parameters with the benefit of a log file. Those two G-code files will be at the same level and requiring those lines of code that initialize a printer to be placed ahead. And not only will I share with you in a video how we do it, but I will share those lines of code that you can just cut and paste and insert ahead of any interrupted G-code file and get the whole thing spinning. We'll catch you in that video.